Hey everyone, here is a video for the topic for notes. So let's start with some important vocabulary. What we're talking about today is parallel lines and the angles that are created when you have lines that are parallel. So if you have a line that is parallel or two lines that are parallel, they should never intersect, so they would never make angles. But a transversal is a line that passes through or intersects two or more lines. So the transversal is what we're going to use, or that is what is going to create our angles. And when you have your lines that are parallel and your transversal, you have angles that are exterior, and that means in relation to the parallel lines. So you see the diagram here. You have lines L and M are parallel, and they're symbolized with the arrows on them. You can see the extra arrows on lines L and M. And so the angles that are outside of the parallel lines are these angles out here. So you have an angle over here, exterior, 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 exterior. So those four angles are all outside of the parallel lines. Okay, there's four more angles that are on the inside of the parallel lines. That's inside here. So there's one right there, there's one right here, there's one right here, and there's one right here. So you have four exterior angles, four interior angles. So those terms exterior and interior refer to, or rather are in relation to, the parallel lines only. Now the next thing is the words alternate versus same side, and that's in relation to the transversal only. So alternate means they're on different sides of the transversal, where same side means they're on the same side of the transversal. And with this relationship, there's 5 different angle relationships that we will have when lines are parallel with a transversal, when you have parallel lines with a transversal. So you have alternate interior angles. There's 2 pairs of alternate interior angles. So you have angles on they're opposite sides of the transversal, but inside the parallel lines. Alternate exterior angles, same thing. Now they're on opposite sides of the transversal, but outside of the parallel lines. Then you have same side interior. They're on the same side of the transversal, but inside the parallel lines. Same side exterior, same side of the transversal, but outside the parallel lines. And then the last one is called corresponding. That means that these angles are in the same position, but it's kind of a translated angle from one spot to the next. So let's take a look at each, what these look like on the next page here. So here we can see that we have a line, and I'm going to use, so let me use the color pink to symbolize the lines that appear parallel. So you have line A appears parallel to line B, and then we have the transversal, which I'll use the color green for my transversal. So the green is the transversal. So these angles that are right here, angles 1 and 2, these angles are in the same position but 2 different places. You have one that's outside of the parallel lines, the other's inside the parallel lines, but they are on the same side of the transversal. This is an example of what corresponding angles look like. Now, there's 4 different pairs of corresponding angles. Top left, top right, bottom left, bottom right, bottom right. So those are the 4 different pairs. And now, when you have these corresponding angles, one of 2 things could be true. If you know the angles are congruent, if this angle 1 is congruent to that angle 2, then this line A must be parallel to line B. The converse of that is, if you're told that the lines are parallel, then those corresponding angles must be congruent. So if we know one of those facts, then the other fact must be true. So there's an example of corresponding angles. Okay. Next, alternate interior. So again, let's look at I'll use my pink color for identifying the lines that are appearing parallel. So you have line A and you have line B. I'll grab the green for the transversal here. So there's your transversal and the 8 angles created. One example of alternate interior angles are these angles 1 and 2. Now, one thing I like to do, or we will see in the future, is when you have alternate interior angles. Let me grab a different color here. How about this blue color? And I'll make this line a little thicker for like a highlighter. Is sometimes you'll see we refer to this as like, can you identify a shape that's kind of like a Z shape? And these angles that are inside of the Z in that shape are the alternate interior angles. And again, if the angles are congruent, the lines must be parallel. Or if the lines are parallel, then the alternate interior angles must be congruent. Okay. Down here, now I'm looking at when you have alternate exterior angles. So I have my lines that are parallel. Okay. I have my line that represents the transversal, and then my alternate exterior angles. This angle EGB is on the right side of the transversal, but outside the parallel lines. This angle CHF is on the left side of the transversal, but outside the parallel lines. So these are alternate exterior angles. And again, if those angles are congruent, then this segment AB is parallel to segment CD, or if the segments are congruent, those angles must be congruent. Alternate exterior angles must be congruent. So we have corresponding, we have alternate interior and alternate exterior, and now the same side interior and exterior angles have a little bit different relationship. These angles, the corresponding, the alternate interior, alternate exterior, the relationship is the angles are congruent if the lines are parallel. On the other hand, the same side interior and exterior angles are when you have your lines that are parallel and you have your transversal, then this angle 1 is certainly not congruent to this angle 2. They are not the same measure, but they are supplementary. These angles are supplementary, which you remember means if you add them together, the sum of the angles is 180. Okay, so if these angles add up to 180, then you have lines that are parallel, or if the lines are parallel, then those angles must add up to 180. Same side, they're both on the left side of the transversal, they're both inside the pink parallel lines. Okay, last one, same side, exterior. Here's where your lines are parallel. Oh, wrong color, let me get the pink color. There's your lines that are parallel, right? Here's the transversal. Okay, this time you have an angle EGB up here. Click on that one. EGB is up here, right? And then FHD is down here. So both of them are on the right side of the transversal, but outside of the parallel lines. You have an obtuse angle right here, you have an acute angle right there. If the lines are parallel, this obtuse angle, this acute angle must always add to 180. Or if these angles add to 180, then the lines must be parallel. Okay, so there's the 5 angle relationships with the parallel lines. Now let's look at how I can use lines that are parallel to help me find missing angles in a diagram. In this diagram, we are told, let me use the pink, that segment RS is parallel to segment QP. So I'm going to mark that on my picture. Here's segment RS, here's segment QP. Those segments are parallel. I identify that with the arrow. Okay, so now if the segments are parallel, then all 5 of these things are true. If segments are parallel, then same side exterior and interior angles are supplementary. If segments are parallel, then corresponding alternate interior, alternate exterior angles, those are all congruent angles. Okay, so I can use that fact to help me out here. So there's one piece of information. I have 2 lines that are parallel. This segment is parallel to this segment. Okay, and so now you have actually 3 different lines that could act as a transversal. The line RQ could act as a transversal. The line segment QS can act as a transversal, and also the line segment SP, because remember, a transversal means it's a line or line segment that intersects 2 or more lines or line segments. So I have these 2 lines that are parallel. Let me bump up the thickness here. So I have, again, a line parallel to this line parallel. Okay? So I can use those relationships. And then the next thing is I have this piece of information right here that says segment PS is perpendicular to segment QS. So I'm going to find, where's PS? It's right here. PS is perpendicular to QS. That's right here. And what I know is that when lines are perpendicular, segments are perpendicular, they create a 90-degree angle. And then the last fact you're told is angle OPS is 115. Okay, so let me shrink this down a little bit and start thinking about some math. Now, at the same time, I'm going to do some justifications here. So first thing I see is with this exterior angle 115, okay, I see right away that I have a set of linear pairs. So if this angle is 115, then this angle right here must be 65, okay, because those two linear pairs are supplementary. And I started my things down here, but let me add to this. So I know linear pairs are supplementary. So I have 115 and 65 to justify that. Okay, next, as we said before, that we know perpendicular lines make 90-degree angles. So this angle right here must be 90, and I have down here that perpendicular lines make right angles. So that's where that 90-degree angle had come from. Okay, as I move forward, I say, okay, well, I've got this shape right here, QSP. I see that as a triangle. So my eyes tell me, well, if I know two measures of a triangle, then the third angle must be the remaining piece to add up to the triangle angle sum is always 180. So if I have a 90 and I have a 65, that means that this angle here must be 25 degrees. So let me go back here, and I say the triangle angle sum is always 180. That justifies how I said I had a 65 and a 90 and then a 25. Okay, and the last thing was I wanted to find the measure of angle RSQ. So let me say here's angle RSQ. RSQ is this angle right here. Now remember what I said before is if I can recognize parallel lines, and when lines are parallel and cut by a transversal, and you can identify this kind of Z shape where the top of the Z is a line that's parallel to the bottom of the Z, then the angles inside of this Z are called alternate interior angles. So parallel lines make alternate interior angles congruent, which tells me that the measure of this angle RSQ must be 25. Okay, and then to just finish up my justifying, parallel lines make alternate interior angles congruent, 25 and 25. Okay, so there's how I can use parallel lines to help me find a missing angle in the picture. Okay, and let me just finish this up by saying equals 25 degrees. Okay, now one more question we'll do together here is down here. This time we know that segment CU, now forgive me when I cut this picture out, the point U is a point that's right up here. There's where point U is. Segment CU is parallel to segment BZ. So here's what I know. These segments are parallel. And let me make this a little thicker. CU is parallel to BZ. And I'm going to mark that with my arrows. Okay, those segments are parallel. So now in this case, the segment VY can act as a transversal, and the segment XY also can act as a transversal. Okay, I'm told that the measure of this angle here, angle UVW is 108. That's right here, UVW is 108. Okay, and I also have the measure of angle VXA is 40. VXA is 40. That's that one right there. Now, as I go through this, I don't generally look at what I'm trying to find in order to do this. I would just typically I would just start, looking at the diagram and finding all the angles that I'm missing. But for the sake of having a concise video here, I'm going to look at it like this. Okay, so let me start with this angle VWA. I'm going to find VWA. That's this angle right here. And I want to see, is there a good way I can find a really easy, quick way I can find this angle? Well, I'll tell you this, is that when I had that angle that was 108 there, this angle right here, that's made by this line and that line, since these are parallel, do you see how, again, there's a little Z shape that happens right here with the 108, and then this angle right here that I want to find is VWA. So when lines are parallel, they make alternate interior angles that are congruent. So this 108 and this angle, which is called VWA, those are alternate interior angles. So I can say parallel lines make alternate interior angles congruent, 108 and 108. Now let me go back here to my drawing tool and make this a little smaller. So this has to be 108. Oops, sorry, not that one. This one, 108. That one can't be 108 because that's a linear pair. They have to add to 180, and 100 and 100 is more than 180, so that won't work. But I could try my eraser tool here and get rid of that part. Okay. All right, so now let's move on. Let's grab a different color here. How about purple? This is angle XAW. Where's angle XAW? That's this angle right here. Okay, I want that angle right there. Now, this angle is part of this parallel line and that transversal. That's different from this group of angles. So this angle has nothing to do with these 108s, but instead is related to this angle over here that's 40, because now I have a parallel line and a parallel line and this transversal. Let me highlight that transversal in green. Use a little bit thicker line here. This is my transversal for the parallel lines on this side. So now what you see is I have this angle that's 40 and I have this angle XAW that's much bigger than 40. 40 is the acute angle, this is the obtuse angle. So those two angles are both inside of the pink parallel lines, and they're both above or on the same side of the green transversal. So those are called same side interior angles. And when you're told the lines are parallel, then those same side interior angles must be supplementary. So 40 plus 140 is 180. So the parallel lines make same side interior angles supplementary, 40 and 140. Okay, and one more thing here, ask me to find the measure of angle XAB. So try to find that angle XAB. What color haven't I used yet? Pretty much all of them. I'll just use the yellow one. XAB. Okay, XAB is this angle right here. Now there's two ways you can find that angle. There's two ways, because I could use the 40-degree angle here when I see this Z shape and say alternate interior angles are congruent, or I can notice that I just found this is angles 140 and those two angles make a linear pair. So that's what I did over here. Oh, I changed my text color. That's how it happened. But anyway, I said linear pairs are sup. So 140 and 40. Okay, so that's applying some of the definitions. Now, I didn't apply all of the definitions of the 5 or all the angle relationships, but that's at least a few of them. But that's how we can do this. So if you recognize or you're told lines are parallel, that means that all of these things now must be true. Okay, so you can use that to complete the first two activities from Desmos in both number 1 and number 2 for topic 4. Bye-bye.